Alright, welcome to STA 3032 Python videos. We'll go ahead and start our Jupyter notebook. It should open up your terminal window like that and open up a browser. That brings us into all of our different notebooks that we have. We're going to go into basic stats and linear algebra today. So video 6, if you're following along, you can download that through web courses in the files section. Alright, let's get started. So this is basic stats and linear algebra. Go ahead and hit Control Enter and run these things. This command right here just gives us IntelliSense, so this actually doesn't need to be typed at all. You can run it without that. But like we've learned in other videos, we're importing NumPy. If you just Google NumPy, go up here, open another tab, throw that in Google, and you'll see that NumPy has their own website. If you go to this website, you can learn all about it. But the one line up front, NumPy is the fundamental package for scientific computing with Python. So everything that we're going to use in this class that does any kind of computing will have the base of NumPy. So SciPy and all those other libraries rely on NumPy. So for this video, we're going to do just basics, scientific stats and linear algebra. So we're just going to go ahead and hit Control Enter on this, and it'll run that command. You'll see it has a number 2 there, which means it's executed. And now we've imported all the NumPy libraries, and we're using the keyword np. So wherever you see the word np, that's referring to NumPy. So we learned earlier we can make an array simply by, actually this is called a Python list, with just square brackets and comma values in between it, and that creates a list in NumPy. In Python. When you put np.array, it creates what's called a NumPy array. And with NumPy arrays, it gives you much more functionality. So let's go ahead and run that. So now we have 2 NumPy arrays, x and y. We've assigned them to the values of x and y. And they're basically a vector, if you will, in math terms. So this vector is 1, 2, 3. It's a 1-row, 3-column vector. And y is the same thing. It's a 1-row, 3-column vector with the values 6, 4, and 2. And now you can do basic operations. So if you add the two together, you'll see that you get the column-wise additions of each of the values. So you see 6 plus 1 is 7, 4 plus 2 is 6, and 3 plus 2 is 5. So that's what you get this. We didn't assign it to anything. If we wanted to assign it to something like z, oops, let's get that out of here. So if you assign it to z, it doesn't print it out, but if we printed out z, now you'll see z contains that value. But if you do an operation and you don't assign it to anything, it puts it in a temp variable, and you won't have access to it again. I guess garbage collection will come pick it up and throw it away, so you don't have to worry about memory space, but you won't be able to re-access it later. So these next couple of commands, we don't actually store it to anything, so it just goes into the garbage collector. So now if you do x minus y, you'll see it's going to do 1 minus 6, which is where you get your negative 5, 2 minus 4, negative 2, and 3 minus 2, you get your 1. So standard basic operations are going to do element by element, row-wise math. So if you multiply them together, you get what you would expect. When you multiply the row values by themselves, same thing with division. And it gives you here, you'll see it gives you a floating point number, so you have the decimal places. And if you do a scalar, which is just number 2, times a vector, you'll do element-wise, you'll multiply 2 by each of the different elements inside this array here. So I'm trying to leave that up, and you'll see basically it doubles each of these elements. And same thing with addition. It's going to do element-wise addition on each one of those. Divide by 0, just like in math, you're going to get a warning, a divide by 0. So, but it gives you back an array of infinity, because if you divide by 0, you basically get an infinite value. And so that's what you get back here. That's what INF stands for. So those are infinities. It actually gave you a value, but it gave you a nice warning to say, did that what you meant to do? You did a divide by 0. Now there are some methods that you can run on your different NumPy arrays. So if I type in sum, SU, and I hit tab, you'll see that sum comes up. So there's something we can do. We can sum the array, and that's going to do go back to your x here, it's going to add element-wise within your array and add them up. So 3 plus 2 plus 1 is 6, and that's where we got our sum of 6. Now, that's x and y were both one-dimensional arrays, but we can actually create multi-dimensional arrays. They're similar. Our single-dimensional array, we had one outside and one closing bracket, so we still have that for our multi-dimensional arrays. But now inside, instead of having single elements, we actually have more arrays, comma separated by the array value. And you'll see what that does is that gives us, we just plot out z, print z out here. You'll see that we get a 2-row, 1-row, 2-row by 2 columns value. And if you do the sum on that, it's going to go element-wise across here and add the, so it'll go across the rows, add the rows, and then it'll add all the columns as well. So it'll give you one sum of your entire multi-dimensional array. So you'll see there, 5 plus 6 plus 7 plus 8. So you get your value of 26. With multi-dimensional arrays, you can do the same addition and subtraction and multiplication that we did earlier with the single-dimensional arrays, but it's going to do, again, element by element. So it'll do row 1, column 1, plus row 1, column 1 here, and then row 1, column 2, row 2, column 2, that kind of thing. It'll go across and sum them up element by element, and that's how you get this. So this is how you'd expect the math to work in stats class, or I'm sorry, in any math class if you're doing matrices. But if you just do it as Python lists, it acts funky. It doesn't do your element by element. So when you're doing linear algebra or anything in math with matrices or vectors, make sure you're using NumPy arrays rather than just Python lists. Again, the scalar, so if you have a scalar which is a constant, or constant times a matrices, it's going to just be multiplication of each individual value. All right, now real basic stats. Remember what x was? It's an array, or a vector of 1, 2, 3. If we get the minimum value of it, you'd expect it to find the element, or the value 1, because that's the minimum, right? So it shows you that's what it is. Finds the max, we should get 3. But what's the mean? Should actually calculate the mean for us. And that happens to also be, let's see, with our IntelliSense, you can see mean. There's a bunch of different, if you hit dot tab, it shows you all the different methods that you can actually apply to that. So there's a bunch of different methods that you can apply to this NumPy array. Mean is the one we're going to apply here. And you see that gives you the value 2. If we print out, okay, so in class we learned the variance is, for a sample, is 1 over n minus 1 over n over all n, the individual xi's subtracted from the mean squared. That's the definition of variance. So go ahead and print out our x, 1, 2, 3, and we'll print out the variance, which is using the var keyword, and then we pass in the DDOF. So what is DDOF? So let's go find out what that means. So we go Python NumPy DDOF. Let's see what happens here. I lost my internet. Oh, there we go. Okay. So what is DDOF? Delta degrees of freedom. That's what DDOF stands for, and it's how we get the non-biased estimate of our, in this case, of our standard deviation and variance. So you'll see that we're using DDOF of 1. That means we're subtracting by, we're dividing by n minus 1. That's what the DDOF does, and that's when it's a population, you would have a DDOF of 0. And if it's a sample size sample, you remember you're going to have n minus 1, so that's where you get the DDOF, delta degrees of freedom. In our class, we just call it degrees of freedom. So you'll see that variance is calculated using the var and DDOF. Standard deviation from a NumPy array is the same thing. You just do std for standard deviation, and you can use the delta degrees of freedom, or you could do the same thing with and you type in sorry, oops, I'm just doing and times raises it to a power, and it's the square root, so it's 1/2. So these two things should give you the same thing. So go ahead and print this one out first. So comment that line out, and you see that if so the hashtag means comment, so it's not going to run that line of code. We see x.var ddof equals 1 raised to the 1/2, so we're square rooting it, equals 1. So now if I comment this out, run this one, you get the same thing. Square root of 1 is 1. So variance and standard deviation equal 1. Okay, let's go ahead and learn a couple more commands here. The argmin versus the minimum value. We learned min earlier, right? So when we did min, we got the value of 1. But if you do argmin, argmin is going to give you the index of the minimum value. So if I control enter there, you'll see we get a 0. So that's the index where the minimum value lies. So in this case, 1 is our minimum value. It's at index 0 because Python is 0 based. So the element 0 in this array is where our minimum value equals. So if we access, let's go ahead and put that out. Oops. So you'll see x, and then we can index x based on the, so if we go to 1, that should be the second element in there. You can index the different elements within inside an array based on 0, 1, so I can go to 2. So you'll see that I can index 0, 1, and 2 within this array using the square brackets next to our x. But we also learned that oops, that's not what I meant to do. X.argmin. So that should give us now the value of 1 because we're indexing the index of our minimum value, and we can also see that that is equal to our minimum value. So the indexing at our minimum value is equal to our minimum value, and that shows, the Python shows that that's true. And then our argmax should give us the index of our max value, and again it's 0 based, so 0, 1, 2, that is our max value. So that's how you index and find minimums, maximums, standard deviations, and variances, which is very basic stats. This video I'm going to try to go in a little bit more into like algebra, linear algebra stuff for just to show you the general use of it. Later on we'll go into much more stat specific stuff. But again, we're going to create a multi-dimensional array, which is a matrix basically. So remember, outside parentheses are here, and then within the outside parentheses we have 2 vectors that we're creating. So we're basically creating an array, or a matrix, that has 2 rows and 3 columns. So let's go ahead and print that out. You'll see 2 rows, 3 columns. There we go. And what does that look like in terms of a shape? You'll see that it comes back with a shape of 2, 3. So 2 rows, 3 columns. Now you can take the mean of that, and that's going to take the mean of all the values as if it was in one data set. So it's going to take the mean of 1, 2, 3, 4, 5, and 6. And you'll see that the center of mass for all those values is 3.5. And that's just if you consider each one of these are xi's. We sum over the xi's and then divide by n to get our mean, or center of mass. The max is going to go through element-wise and find the max of all of the values within the matrix. And then our argmax, what does that give us? That gives us the index as if this is one long list. So 0, 1, 2, 3, 4, 5. That's where we get our argmax. So now if we do something like a index of argmax, you see you get an error because it's not really the fifth element, because it's the matrices now. So you'd have to do what's called, oops. So you'd say it's in, so if you do that, you'll see you get that array. because now you've got the second list, and then you would do 2. Oops. So now what you're doing here is you have your matrix A. You're saying I want to go into row 1, which is actually the second row because it's 0 based, and I'm going to the second index, which is really the third value because it's 0, 1, 2. So that's how you index a multi-dimensional array. So grabbing the arg min of the matrix does not give you the index into the matrix A of where you need to be. So keep in mind that that's not a valid syntax for finding it. So transposing now, switching between rows and columns. We have our value of A, which is a 2 by 3. And then if we transpose it, which is our dot t, so if we transpose it, it's going to flip the rows and columns. So now look, B is 2, 3, 1 is our first column, and 4, 5, 6 is our second column when you transpose. So for linear algebra, sometimes you need to do the transpose, or you need to do the flip the rows and columns. So for linear algebra, this is a very helpful and efficient way to do linear algebra in Python. So what does the shape of B look like since we've transposed it? It's now 3 rows by 2 columns. Now let's create a new matrix of C. We're going to do a new method called randint out of the numpy. So let's just look so we have np, which is our numpy. There's a random namespace, and within that random namespace there's this thing called randint, and you give it a minimum value that you want it to be at and a maximum value, and it's going to pick random a number between those two. So if I wanted to pick something between 3 and 7, I could do something like that. Remember, I commented these 2 lines out, so it's just going to be this one printing out. So I hit Control Enter. See, it picked the number 6. If I run it again, it picked the number 3. So every time you run it, it's going to give you a new random int between the values of 3 and 7. And if you actually look this up, go to Google. Can't do that because it's going to put it in there, otherwise it'll think it's a namespace. Okay, so you go to randint, and it tells you our low and our high, and then it's going to output in the shape size. I'll go over that in a second, but random integers from the appropriate distribution, such as random int, if size is not provided. So it's going to give you 1 if size is not provided, which is what we did. But going through this scipy.org documentation, it'll give you all that you need to know about randint. So if there's something that you need to use and you don't know how to use it, Google it, go to this website scipy.org, and then it'll show you examples on how to use it. So if I wanted a randint from 0 or 1, which is our size 2, and then you give it a size 10, it's going to create an array of those. So this gives you examples on how to use it. So if there's a method or something that you don't know how to use, throw it in Google, find the documentation. A lot of times there's examples on how to use it. But one of the other things that you can do with randint, delete this, okay, is you can create matrices using randint. So we give it we want numbers between 0 and 10, and then we give it a shape. So we want to create a matrices that's 2 rows by 3 columns. So what does that look like? There you go. So it created randints between 0 and 9, because it's 1 less than that. And you'll see that it created a 2 by 3. Prove that by doing the shape attribute on it. So now, element by element, if the shapes aren't the same size, we're going to get an error. So remember, A shape is a 2 by 3. And B shape is a 3 by 2. So if I try to do element by element addition, it's not going to work. So what does that look like? It gives you an error, and you'll see that this is Python telling you that it did not work, and it shows you the line of code it didn't work. The A plus B is the line of code. There's only one line of code in this cell, but that's where the error happened. And then it gives you what the output of the error was. Okay, because we tried to broadcast with different size shapes, it wasn't able to do it. But we know A and C are the same size, so C is a 2 by 3, and A is a 2 by 3, so we can element-wise add those. So what does that look like? It's going to do element by element additions from the array A and the array C. In linear algebra, you have to do things like the dot product. If you do A dot B, now for dot products, it's doing multiplication. Your shapes don't have to be the same size, but the first or matrix has the columns has to be the same size as the rows of your second one. So your 3 here has to match the 3 here, and then what's going to output is going to be the number of rows here and the number of columns there. So that's what's going to happen. You should get a 2 by 2, and it does the dot product of A dot B. Now, A dot C is not going to work because the columns don't equal the rows on B's size, so you should get an error here. And we do. So that's this video. I hope that was helpful for Python. A little bit on the stats, and as well a lot more on the general purpose math libraries that it has. And we'll be going over some more videos soon.